Here's an example of an indirect proof that have worked out for you. We want to write an indirect proof that negative 4x minus 4 is less than 12, then x is greater than negative 4. So my hypothesis is my given. So I'm given negative 4x minus 4 is less than 12. My conclusion is x is greater than negative 4. So to write an indirect proof, I want to do the opposite of x is greater than negative 4. So you got to think, what's the opposite of greater than negative 4? Well, it's less than or equal to negative 4. Now, I can't do my reasoning with less than or equal on this problem, although maybe I could. But what I'm going to do is I'm going to split it up. I'm going to do less than negative 4. I'm going to do equals negative 4. So case 1 is when it's equal. So I assume x equals negative 4. So when x equals negative 4, my answer to negative 4x minus 4 is 12. Now that's a contradiction because 12 is less than 12. So that's what I say. We want to do a contradiction of our hypothesis if we can. So that assumption is wrong. Then if I do less than negative 4, I get negative 4x minus 4 is greater than 12. That's a contradiction because I want it to be less than 12. Since I got a contradiction in both cases, that means my assumption was wrong. That's what we say. The assumption is wrong. And therefore, our assumption that x is less than equal to negative 4 is false. Since we say that's false, that means our conclusion must be true. That's all we got to do. Now let's do one, clear as mud. Let's do one together. And it's not a total mathematical proof, it's more an application. So if we read this, Marco hiked more than 10 miles on a path, making just 2 stops along the way. Use indirect reasoning to prove that he hiked more than 3.5 miles on at least one leg of his hike. So I want to prove that he hiked more than 3.5 miles on each leg, or at least one leg, I should say. So I'm going to assume the opposite of that. So I'm going to assume that Marco hiked less than or equal to 3.5 on each hike. So in other words, I'm going to have a number. Let's do this. Let's call our first leg, we'll just call it leg 1. I want to be less than or equal to 3.5. Leg 2, we're going to say less than or equal to 3.5. And leg 3 is less than or equal to 3.5. So if I add leg 1 plus leg 2 plus leg 3, that will be 3.5, less than or equal to 3.5 plus less than or equal to 3.5 plus less than or equal to 3.5. Well, that's going to be less than or equal to 10.5, isn't it? We got a problem because we're given that he hiked more than 10.5. Okay? So what we say here, a contradiction. I always put a star when I do contradiction. Marco hiked more than 10.5 miles. Therefore, our assumption is wrong. And we're going to write down what we're supposed to prove. That is, Marco hiked 3.5 miles or more on at least one leg of his hike.